All right, why don't we get started? Today's webinar is sure to be a popular one. We've already had quite a bit of interest in this topic. So this one, and if you've joined some of our previous webinars, you'll sort of follow the story, follow the progression. If you haven't, definitely check them out at powermetrics.app. But this one is going to be the most roll up your sleeves tactical of the current bunch. This is all about best practices in PowerMetrics. We're looking at metrics, we're looking at dimensions, the members within those dimensions, and then best practices for actually how to set up and get your data in a state where it is efficient, performant, and ready, and even AI ready for the future as well. So, anyways, really looking forward to this webinar today. I've got Parker. Selman and Neal Stansby with me today. They're going to be presenting. Parker is our team lead on the success side. So some of you have actually maybe interacted with him in the past. Parker's got loads of experience helping all sorts of different customers. So he's seen a lot and obviously has got a lot of expertise when it comes to best practices for how to set up PowerMetrics, the metrics, the dimensions, the member names. And then Neal, you won't know, but Neal is our Director of Business Operations. So he sits in the back, but he's responsible for all of our data architecture, data comings and goings between all of our business systems. So both Neal and Parker are a wealth of knowledge. They're joining us today. I also have Megan King on the line with us today. So if a question comes up that is more on the success or support side, she's obviously a great person and you've probably interacted with her as well. My name is Alan Ville. I'm the CEO at Cloudfolio, and as I said, I'm super excited about this PowerMetrics session today. So having said that, we're going to get right into it, and I'm going to hand it over to Parker.
Thanks, Alan. Hi, everybody. As Alan mentioned, we'll be going over how best to set up your PowerMetrics experience at the metrics, dimensions, and members level in order to accomplish your end user's goals. So today we'll be getting into what those goals are and what they really mean, and how best to implement a metric solution complete with dimensions and members within those dimensions to accomplish those goals and make sure that your metrics are primed for your users to get the most out of them. Then I'll hand it off to Neal, who will talk in more detail about the data management side of that and how you can best create an architecture before bringing your data into PowerMetrics that can help accomplish these goals. So let's get started. We'll start by establishing what your end users' goals often are. We like to say that users want to ask questions of data the same way they'd ask a question of an experienced data analyst. This means a couple of things. They want to use natural business language to describe their metrics and dimensions. So instead of using the technical names that may be used to help create the implementation, they want to use their everyday parlance, the language they use in their everyday conversations to talk about their metrics. They want to clearly understand the definitions of those metrics. This includes what the data is representing, how it's being calculated, and in some cases, where that data is coming from. They want to easily find the right metrics and trust that they have actually found the right one. They don't want to be confused by duplicate or similar metrics within a solution. They want to find the right metric to solve their problem as fast as possible. And finally, they want to be able to see trends and patterns in their metrics and safely explore their metrics to find more trends and patterns without being overwhelmed. They can be overwhelmed by just seeing too much data, so having too many members available to them, which is something we'll discuss, or having volatile data. So again, without having a metric that's properly defined, you can lose the plot and not have a metric that truly answers the questions that your users are going to be asking. So let's talk about how to actually set up your metrics to accomplish these goals. Before we start, though, I think it's important that we break down some of the architecture on the PowerMetrics side so everyone understands at what stage these steps take place. We support metrics across a variety of different sources, including semantic layers. These are metrics that are defined in a semantic layer like dbt or cube. We run queries in real time and cache the results. And the data is not replicated. So we're not storing it in PowerMetrics, rather just querying it directly and presenting the outputs of those queries. Similarly, we enable connections directly to data warehouses, and this is something that Neal will be speaking on in more detail. Again, these are metrics that are defined in PowerMetrics this time, but data is similarly not replicated, not stored in our tool, and we run queries on demand. What I'll be speaking largely about in my set of slides here are what we call data feeds metrics. So these are metrics that are defined in PowerMetrics, where you're connecting to data, modeling that data, and actually storing that data within our tool, within PowerMetrics. If you're connecting to cloud services, REST APIs, spreadsheets, file uploads, and so on, this will be the mechanism with which you're connecting to that data. We also support instant metrics. These use industry standard definitions from Metric HQ to connect your metrics to cloud data in just a few clicks. Again, this is data that's stored in metrics. These are pre-modeled and often all have the best practices that we're going to be talking about today applied to them already. But like I said, the majority of what I'll speak on is relevant to the data feed side of things. Neal will talk more about the architecture at the warehouse side. So let's get into it. First, it's important we discuss metrics and what metrics mean to us. So a metric describes both a technical and a business concept. This is important because two audiences need to be able to speak the same language when it comes to a metric. A technical definition needs to be established as far as what specific data represents that metric, but from a business user's perspective, they need to understand what that metric means in their context. As an artifact, it refers to a single, meaningful, and measurable business concept. And that specificity is very important when we get into some of the best practices for metrics building. I'll go through a few of the general best practices for titling, organizing, and generally defining your metrics. The first and foremost, most important point is to be precise. It's important to know that a metric has a singular business definition. One of the examples I like to bring up to showcase why this is important is when tracking conversions. Oftentimes, you want to track your conversions across something like an ads platform. But once you create a metric that is for conversions, immediately there's some ambiguity. What type of conversion? There could be dozens of different conversions that are available to you, and having one centralized metric that covers all conversions gets us away from having a singular business definition for a metric. Instead, using a feature like our pre-filtering tools in our metric editor, you can create a metric that is specific to the add to purchase conversions action. So all of a sudden now you have a distinct metric with a singular business definition that is clearly communicated as to what data this is pointing to. Another tip that we recommend is to avoid allowing users to change the aggregations of metrics. So if you're playing around in the tool, this may appear to be a convenient option, and to some users it is, but it's important to understand how this action changes the definition of your metric. For example, if you have a metric that's tracking total sales, inherently that's a metric that is summed. You're summing sales over a given period of time. If you allow a user to view this same metric but aggregated on average instead of summed, then that is a different metric. That's average sales. And those should be separated as such so that your users can find exactly the specific slice of that metric that they're looking for. And we enable the ability to enable or disable the ability to edit aggregation type for your users. And that's on a per metric basis, depending on how you want your users to interact with that metric. We also recommend considering when to create unique metrics instead of just using a dimension within a centralized metric. The example I'll give here is with a new sales metric. You've got a new sales metric and a dimension labeled country. In one case, you may be able to use one metric that is separated across countries, and you can see my new sales in Canada and my new sales in the UK. And this is great if those sales together add up to a larger whole that makes sense to your business context, right? Does all of this revenue get reported in the same place? Is it all centralized like at the end of the year? Then yes, it makes sense to use one central dimension and one distinct metric. But if your new sales in Canada and your sales in the UK are completely different lines of business, they operate on different profit and loss statements, then maybe it's valuable to create unique metrics for this data instead of relying on the one. And again, our pre-filtering tools can help you enable that in the metric editor. And we'll get into showing exactly where that lives in the product in just a second. Finally, it's important to consider the appropriate date handling in your metrics. We offer the ability to handle dates looking at all of the values in your data feed or just the most recent data. So when you want to look at all values, you're looking at transactional data or raw unaggregated data, something like a list of orders from Shopify. Each individual entry is its own distinct transaction. Whereas if you're getting a daily total of social media followers, your total social media followers, that's something that's being regularly updated and is already pre-summarized, right? It's summed up by day. And so in that case, you'll want to set your date handling to use just the most recent values. One other example here that you'll see on the right shows, again, how even though you may be looking at a specific conversion type, you need to use natural language to properly communicate this to your users. So when we talk about using natural language, sometimes you bring in a metric name that might come directly from a service. That's something that's useful internally when making API calls, but not to your end user. And so it's important to use natural business language as well when titling your metrics. Here I've got a couple of examples of various metrics that we see in different types of accounts, some which are adhering to these best practices and some which stray away a bit from it. And so we'll get into those details. Things like failed charges rate, revenue per employee, and net profit margin, I think, are doing a great job at clearly communicating what this metric is pointing to. Not only is it very clear to understand exactly what data we're looking at, and if it's a calculation like revenue per employee, the parts of that calculation are very clear. It's also clear as to what service this is coming from, if that's something that your users are interested in. However, there's a couple examples here that are worth considering if it is the best fit for your users. Things like including the service name in the metric title. You see G ads representing Google ads in a lot of cases. If you have multiple ads accounts across a variety of different services and you need to split these up, perhaps that's important, but it's worth questioning if it is or if it's just a distraction to your users. Similarly, even things like acronyms that sometimes we can take for granted that are familiar to us but may not be familiar to our entire user base, it's worth considering whether or not you want to include an acronym or the full title of a metric laid out. Here is a couple different examples, just highlighting the areas of PowerMetrics where you'll see the features that I mentioned, locking the aggregation type. There's a toggle to turn it on or off, selecting proper date handling, using all values or the most recent values, and then the pre-filtering options. So this is all available while you're building or editing an existing metric. You've got the ability to toggle any of these particular features to really clearly define your metric and how it should be used. Within metrics, there are dimensions, and dimensions provide context for a metric by enabling filtering and segmentation of its data. And dimensions are incredibly powerful within your metrics, and it's important that you understand how best to utilize these so that your users get the most value out of them. The primary thing that we tend to recommend is to maintain an agreed upon dimensions catalog. This is a really critical piece of infrastructure you can develop that centralizes the names of your dimensions and what they represent across your data stack. And this ensures that you're adhering to the best practices we mentioned, that your dimensions are using natural language, that they are in alignment with what your users are expecting. Like I said, using natural language familiar to your users is critical. And we enable the ability to rename dimensions directly within the metric editor, which helps turn technical names that might be coming directly from a service to human readable names that are part of your agreed upon dimensions catalog. It's also incredibly important to be consistent when applying that same dimension across metrics. This goes again to why it's important to develop this catalog. If you have the same key measure that's being tracked across a variety of services, it's important to keep that dimension that might segment each of those metrics consistently titled so that you can perform calculations on those metrics, so that you can explore those metrics using a agreed upon and unified dimension. You can also use some dimension visibility functions that we have built in within the product to control if users can filter and or segment a dimension. So what do I mean by this? Let's think about an example where you've got an account ID dimension on a given metric. You may have hundreds or thousands of unique account IDs that represent sessions or users in web traffic. And so to segment a visualization by those account IDs may not be very useful. That gets to that confusion we spoke about where there's too much data and it's too complicated or not readable for the end user. But you may want to filter by account ID instead of segment by it. You want to look up a particular ID or a set of IDs. And so it's important to enable users to filter when necessary and turn off segmentation when not necessary, or vice versa. And we enable that again within the metric editor. On the side here, a couple quick examples of well-defined dimensions and sort of their poor counterparts. So oftentimes we'll see a dimension labeled type. Like conversions, what does type mean? There could be so many different specific slices of that. And so labeling that as account type is more specific, it's more defined, and it's understandable to your users. Similarly, taking those technical names from a service and converting it into something that's unified across services. So campaign group may be applied across Meta ads, Google ads, and so on and so forth. It's important to establish that consistently and in natural business language. There's a couple examples of how you can set up a dimension catalog. It can be as simple as a shared spreadsheet in your organization, just something to label exactly what you're looking at when you're speaking of dimensions across different categories is enough to make a significant impact in your user's ability to navigate your metrics. And once you have this catalog established, you can rename dimensions within our tool directly so that you are able to apply this catalog consistently across your different fields. Now we can talk about members. So we spoke about metrics, and then below that, the dimensions that make up the metrics. Let's go one level deeper and talk about the members of the dimensions. Members are unique categorical values within a dimension that appear in a data set. In order to ensure that your members are aligned with our best practices, you want to make sure that they're consistent across all of your metrics, all of your dimensions. Now, we showed how establishing a dimension catalog can ensure that you've got that consistency in your metrics, but doing so for members is a larger undertaking, admittedly, and it will require various strategies and ongoing effort to make sure that this is done consistently. New members will appear in your dimensions as your data changes over time, and the formatting of those members across metrics and services may also be different. And so it's important to understand what accepted values for certain members are and take advantage of tools like lookup tables and some of our data feed editor components to ensure that these are standardized. To clear up exactly what I mean by this, a great example is a country dimension that could have a value for UK, but also have a value for United Kingdom, or USA, or United States of America, or United States. All of these represent the same value, but are split across 2 or 3 or more different forms of the same value. And so ensuring that consistency is critical to making sure you're getting the right values out of your metrics. It's also important just to simplify and clean up long or complex member values. We see this a lot with campaigns, ad campaigns that are run. Sometimes technical names will be used to define a campaign within a service, and this makes sense to an ad manager, but not to the end user who's looking to report on insights. So we can use something like our data feed editor to clean up these more technical names to fit with that natural language that we are looking for. It's also important to consider exposing 2 or more dimensions in your metric to capture detailed and grouped members. So we've mentioned a couple times here how you can have a dimension that has so many members that it becomes difficult for your users to parse. But what if those dimension members are actually critical to some of the insights you're able to generate? So if you have an industry subcategory dimension that has hundreds of distinct values, but it is important to your use case that you're able to look at visualizations over some of those subcategories, we recommend finding a sort of a higher level grouping that you can establish that buckets those members into larger groups so you can filter by those groups instead of individually looking through a large suite of members. And again, our data feed editor, through a variety of different means, can help you accomplish that. Here on the side, just as an example of something we see very frequently, this is results of a form that might be asking for a job title. You can have a variety of different responses that mean the same thing or contain the same answer. So this is particularly an issue if you're getting user generated text input. Very difficult to manage in some cases and can add complexity to your member sets. So to manage this, we suggest a few different things. Firstly is using something like a lookup table to properly map to established and defined member values. So to accomplish the solution to that country issue I mentioned, using a lookup table like this country and region lookup table, which we provide on our knowledge base and is available if you want to download it, allows you to map all of your values to specific columns that represent how you want that value to appear in your metrics. And you can use our data feed editor and merge in data from these various tables, similar to how you would do a join in a SQL query, to map these values properly and ensure that you're using consistent member naming across your metrics library. If you don't, if you know, sometimes there's one-off cases where you need to make individual adjustments and you don't have an entire table to do this, our data feed editor has an incredibly powerful suite of functions that allow you to create these mappings on your own, whether you're doing nested if statements like this, or taking advantage of our larger suite of functions, similar to Excel and some SQL and JavaScript equivalents as well. You can do any of the specific data cleanup items that I mentioned, cleaning up your member names, removing underscores, white space, additional cleanup that you have to do, as well as creating that binning and doing that user or member grouping that's important to ensuring that your users have standardized and consistent member names within your dimensions. And this is all possible directly within PowerMetrics. But as we'll move on to the next stage, Neal will talk about how best to set up this architecture at the data level and clean that up for your users that are using warehouses.
Thanks, Parker, and hello, everyone. Good morning, or good afternoon, or good evening, depending what time zone you're on. So yeah, I'm going to talk about data and largely focus on data warehouses. I think given the audience that's on this call, I probably don't need to spend too much time on the definition of data, and you can see it right here. The one thing that is just worth calling out, although I think it's evident from what Parker's shown us already, is there's numeric data, so sales numbers, revenue numbers, temperatures, whatever you want. But there's also sort of textual data, which usually represents categories like geographies or industries and things like that. And as I mentioned, I'm going to be talking particularly about how to use PowerMetrics with a data warehouse. Now, I want to preface this by saying the term data warehouse is a little bit of a loaded term, and it might right away have you thinking about really big iron data warehouses, which are big and expensive and maybe intimidating to get into. And it can mean those things, but it doesn't need to. It can actually be any database, and I'll limit the discussion to SQL-based databases, SQL-based databases. But there's a bunch of advantages to bringing all your data together into a data warehouse and then connecting PowerMetrics to the data warehouse. The first one is it just simplifies joining data from two or more sources at the SQL level. And as Parker just showed you, it can be done within the product, but this is an alternative way to do it. It makes it really easy to create a transformed version of the data. And one of the most common ones we do is categorizing values into bins. And then the last thing is, and this really depends on what your original data source is. Some APIs are fast and some of them are slow. The nice thing, if you're dealing with a slow API, is you have a sort of background task that's updating your data, but when you're interacting with it from PowerMetrics, you're not talking to that slow API directly. You're talking to a database which has been populated and is ready to go. So it can be much more performant. Again, entirely dependent on what the native data source is. And how do you get the data into the data warehouse? Well, those are terms that I'm sure most of you have heard before. The sort of original strategy when people started doing this was called ETL, which is extract, transform, and load. So you pull the data out of the original data source, you apply any transformations you need to do to it, and then you load it into your database. There's a variation on that called ELT, which just switches the order. You extract, load, and then transforms. or if you have no transformation, of course, you can just extract and load. Out of the three, ELT is the most flexible, but it requires a little bit more storage. It requires more storage because you're storing the raw data that you extracted and loaded, and you're storing the transformed data. But what you get in exchange for that little bit of extra storage, and storage is honestly pretty cheap these days, is flexibility. So if you're in the situation where you're serving multiple customers who want to see the same source data but presented in different ways, formatted, binned, transformed in different ways, it's a lot easier if they all can access the raw data and then apply their own transformations. So I'm going to walk through a little bit of an example, and this is based largely on something that we set up internally. Really, it sort of serves two purposes. One is it helps us run our own business, but we also use it extensively as we were developing the feature that we have called direct-to-data warehouse, which makes it really easy to connect to these types of data warehouses. So what I ended up doing was putting together a pretty simple data warehouse that pulls data from a bunch of different data sources and makes it available to PowerMetrics. So the first source I'll talk about is our CRM system, where we have information about our customers. Our CRM happens to have a fairly slow API, and it also often returns these kind of cryptic internal representations of values rather than user-friendly ones. So the strategy I opted for here is export, transform, and the transform here is mostly mapping those internal values to more human readable ones, and then loading that into our data warehouse. So we've got one database in our data warehouse, one data schema, which it's the same data that's in our CRM, but it's been transformed in a way that is pretty universal for all the different ways we're going to consume that data. We also connect some of our internal product data to our data warehouse. So when we're looking at our business, it's useful for us to know how many metrics has a customer built, how many dashboards have they built, how many users do they have in their account, and so on. So that type of data comes from our own internal product database. And it's that we elected to just bring in directly. There was really no reason to transform it. We're really used to that form of data, so dealing with it in its raw format was the right way to go. The third one I'll talk about is our billing system. So that's interesting data for us because it tells us, how much is a customer spending, how long have they been spending, those types of things. And in this case, our billing system happened to have an API that was really well optimized for a bulk export of raw data. So in this case, I chose to do an ELT flow. So I export the data, I load it directly into a raw billing data schema where it exactly matches what's in the native system. But then I also transform it into a slightly more derived version. And this is doing things like taking MRR or revenue numbers and splitting them up between our two products and so on. So really not very end user specific, just more sort of business specific type transformations. So if you're going to use the direct-to-data warehouse functionality, one of the requirements is that for each metric, PowerMetrics needs to be able to pull from a query that accesses a single table. If the source data is actually the data that you're interested in for your metric comes from multiple sources, then they need to be joined beforehand. And there's really two ways you can do this. If the data volume's small and that join happens quickly, you can use what's called a view, and many of you may be familiar with views. In SQL, a view is really just a SQL query statement, but instead of running it on demand, it appears like it's a table in the database. But every time you access that table, you're really running the underlying SQL query in the background. And that's useful because it can, now you've got something that looks like a table, therefore it can be consumed by our direct-to-data warehouse feature, which is what we're trying to get to. Now, there's cases where that's not practical, and really they boil down to two things. One is if the data volume starts to get huge, that's inevitably going to make things slow. But the other is sometimes joins themselves can be slow, and you may run into this, for example, if you're joining on a text string and it uses a different collation in one database than it uses in a different database, that can really slow down the join. So if for whatever reason you find that a basic view is not cutting it for you, then a materialized view could be a better choice. So what you're doing with the materialized view is you're using the same SQL query to select which data and to join it, but instead of doing it dynamically as a view, you're writing it to an actual table. And of course, you want to update this periodically. How often you update it is going to depend on how often the source data is being updated. Um, Again, it's a trade-off. It uses a little bit more storage because you're now storing the joined view, but it can be much, much more performant if the query itself is slow to execute. So going back to the data warehouse that we built, the four green schemas that you see up here are the ones I talked about before. But now what I'm showing you is a sort of hypothetical example where I'm setting up data for two customers, and let's say they're Alan and Megan for the sake of convenience. And Megan asked for something that's really simple. So for her, I just build a simple view. It only draws from three of the sources, and I make it available to her, and she connects to it with directed to data warehouse, and off she goes. For Alan's case, he's bringing in data from different sources. The join is more complicated. There's more rows and so on. So in this case, I've opted to do a materialized view. The important point here is that the data at the green layer that I've shown is it's mostly raw data. In the cases where it's transformed, it's only transformed in ways that are kind of universal to your business. Like I said before, things like partitioning data based on product and things like that. But I'm not making assumptions about who the end user is until I get to the second level, which is the actual views, which is what's going to be consumed by PowerMetrics. So now I'm going to talk about really some of the learnings that we went through as we set this system up. The first one is why I'm really recommending that structure that I just showed you on the previous slide. Keeping the raw data separate from the views really simplifies managing the multiple data sources and the data normalization. Um, and as I said, it lets you sort of customize the view depending on who's going to consume it and how they're going to consume it. So a really good example of this is, Parker talked about dimensions and filters. And if you're going to filter or partition your data based on one of the members, let's say geography, indexing that particular column in the view can massively improve the performance of queries and therefore the responsiveness of PowerMetrics when you're using the directed data warehouse feature. How much it improves performance and whether it's worth doing is going to depend on your data. It's going to depend on what your underlying storage mechanism is. But for sure, if you're using a row-based storage database, especially if you're just getting started and using a simple relational database, indexing is really critical. Keeping the views separate from the raw data also lets me customize binning and mapping on an as-needed basis. So if you look at the screenshot that's at the bottom here, you can see that this user was interested in binning this activity age data based on sort of how long after the account became active did they perform this activity, and they're binning it in a very specific way that makes sense to them. And it's quite possible that the next user might want the same data, but they might want it not binned, or they might want it binned differently than how the first user did. And this, by keeping each one of them in a separate view, it really stops the complexity from getting out of control. Each one's tightly associated with an end user and an end purpose, and can be really optimized and tweaked for that. And then the last thing, going back to, again, something that Parker mentioned about having both human-friendly and standardized names for things like dimensions. What we do is in these finalized views that are actually going to be consumed by the directed data warehouse, we rename the columns to actual like user-friendly things with spaces in them, which if you're used to working in SQL databases, you'd almost never have a space in a table name or a column name. But when you get down to these views, the only reason these things exist is to be consumed by the direct data warehouse feature. So you can give them nice human-friendly names. The next thing we ran into that I think many people will run into is it's not uncommon to have different sources for the same piece of data. So you may recall, if you're the person that signed up for Clipfolio, that during the sign up process, we ask you how big your company is, how many employees there are. Um, so that's a piece of data that we have, and I've represented it in the screenshot below here as company size KF for Clipfolio. But our CRM also has a database of companies and how big they are. And it's going to give me a different datum for the same question. For the same company, one of them says it's a 250 person company, one of them says it's a 100-person company. So what do you do? Well, one thing you could do is just decide which one you're going to keep and throw the others away. But we opted not to do that. The practice that we've followed anywhere that we have sort of the same data, but sourced from different places, which will have varying accuracy, there's three important things that we do. The first one is we keep them all. Okay, so you're never throwing data away. If you decide you want to change which data source you're using in the future, you still have the old data. Which brings me to the second one, is we have the concept of an accepted column. This is saying, of all these other different sources that I have, which is the one that I have chosen to use because I think it's the most accurate. And we have a source column that tells us where did that data come from. Now, if you look at the first two rows here, it doesn't matter. Sorry, it does. But my point is, there could be the data could come from multiple places. You want to remember which one you chose as the accepted one, just so that it's clear where this data came from. It gives you sort of the provenance of your data. And then the last thing we did, it's not really captured in the screenshot, is we versioned all of this. So that means that we've captured all this data, but at some point someone looks at it and says, "Hey, company X is showing up as 250 people." But it's really not. It's closer to 100. And I can go in and look at them and say, oh, that's because we're pulling that data from our CRM. And instead, we're going to use the 100 people that they gave us as their answer to the sign-up question because it's more accurate. So I changed the size source, I changed the size accepted, and the system records who it is that did that and when they did it and why. And that's really useful because one thing that happens all the time with data is people see a value that they didn't expect to see, and they question, like, why am I seeing this? Where did it come from? And this really gives you a nice kind of audit trail of who changed what and why and when. And that can be really valuable for answering these types of questions. And the last thing I'm going to mention, and again, this is something that Parker talked about, how to do this natively when you're using data feeds or semantic layers, but this is doing it with the data warehouse, is managing sort of slightly different formats of the same data. So countries and industries are a great example. For some of these, like for countries, for example, there are standards. There's an ISO standard of codes for countries. It's a good idea to use that, but you can't necessarily dictate that the data source that you're using provides data in that format. It may insist on providing you with just plain old strings. And that is certainly the case that we ran into. So, a classic example is we have United States, we have United States of America, we have USA, we even have things like United States minor outlying islands and so on. And so what we do is we have a bunch of many-to-one lookup tables that normalize this data and prevent you from falsely splitting these segments or falsely splitting these dimensions. We recognize that all of these, for our purposes, want to be treated as the United States, and so they all get reduced down to that. And at the same time, the same table can provide sort of mappings and binnings. And again, back to something that Parker mentioned, is in addition to knowing the country, which can be really interesting, but can have a huge number of possible values, you may also want to have a sort of more broad binning of either world region, sort of based on geography, or economic region based on sort of economic geographies. And that can all be accomplished in the same lookup table. And this is used in your transformation process and or in your view building process to normalize the data, bin the data, and get it into the form you want in your final views. And the last thing I'll say on this topic, and it's actually my last comment overall, is if you're doing this, one thing you have to be careful of is to audit regularly for misses. So, of course, the first time you run this and test this, you're probably going to have data for United States, but you may not have data from, uh, some small African country that, recently went through some political upheaval and has changed its name or something like that. Um, so if you're not careful, you can be relying on this lookup table, but it could have missing values and you end up dropping data. So if you're using this approach, which I do recommend that you do if you're using a data warehouse approach, just make sure that you have a check in there that's detecting if any of your data failed to map when you use the mapping table.
All right, amazing. Lots and lots of knowledge. Thank you, Parker. Thank you, Neal. There's two questions that came in that I want to see if we can get to before we break, unless there's more from the audience. But the first one is somebody here was saying, I'm using what looks like the data feed strategy right now. We've got data coming in from various APIs, from marketing material. Can I mix and match that with a warehouse? And is that maybe the best practice? Should I move everything to the warehouse? I'll let either of you answer that.
Sure, I can speak on it first, I think. We see a variety of different applications. Many users do use a best of both worlds approach where they have some data in a warehouse and some data outside of a warehouse, depending on their ability to push the data from the cloud services to a warehouse. In general, we say if it's possible and if it's something that you think is feasible for you to do, moving everything to a warehouse does simplify the process quite a bit. A lot of the caveats I mentioned about ensuring that labels are consistent across different services, that process is much easier if you can do it in one centralized place versus trying to manage a whole host of services at once. I will say for some users that maybe don't necessarily have the technical staff to perform a full overhaul and move over in that direction to a warehouse, we've seen success with some users using kind of off the shelf ELT and ETL tools, like Fivetran, for example, to push data from some of these cloud services to a dedicated warehouse for relatively minimal cost. And that eases that process a great deal and is also something we're happy to provide some guidance for via support.
I'll maybe just add to that to say I totally agree with Parker's answer in terms of steady state, but I'll add that having a bit of a blend of data warehouse and data feeds based can be useful as a transition strategy. I mean, Rome wasn't built in a day. What I showed you, the data warehouse that we built, that took quite a while to build, and for sure, almost everything that exists there now in the data warehouse originally existed as a data feed. So, if nothing else, a mix of data feed and data warehouse can be a good sort of intermediate state as you're maturing your data architecture.
Okay, that's great. And the other question had to do with renaming dimensions. So this person says, thanks, Neal and Parker. I wasn't aware of the ability to rename dimensions. I guess the question is it safe to do? Does it change the underlying field names, or is this safe to do? I think that's the crux of the question.
Yeah, that's a great question. So the dimension renaming feature that I showed, which is part of the metrics editor, does not rename underlying fields. And that's a really important distinction to keep in mind. What this is doing is essentially masking that field name in your data feed for your metric. So you're not going to be undoing any of the relations you've made, any of the functions that rely on those critical field names. But I should also mention that if you're using a lot of forethought when building your metrics, you can at the beginning when you're creating your data feeds, rename your columns in the data feed editor to match your established dimension catalog, those standards. That's an extra step you can take that prevents you from needing to edit every single dimension once you're in the metric editor stage. Yeah, you can do it once for a data feed, and then any metrics you build from that feed will have those dimensions applied. But if you're not using a centralized strategy already and you want to retrofit your metrics to make sure they're using best practices, you're totally safe to edit your dimension names in the metric editor.
Yeah, thanks, Parker. That's a good point. I mean, you can obviously, if you're using a direct to warehouse, in the warehouse you can, as Neal was saying, you can make views that have user-friendly and consistent names. You can use the data feed editor to model and cleanse the names of the dimensions. And as maybe a last step, because there's always a last step, you can do that in the when you're building the metric itself. So you can rename the dimension. And I mean, these things are super important because anytime you're building a calculated metric, you need those dimensions to be aligned. Otherwise, the calculation won't work for that field or that segment. So, okay, wonderful. I don't see any other questions that have come in. Obviously, we are always available for help and support. All of us here are super passionate about metrics and data analytics, so reach out to us. We've seen a lot and are always happy to help. We're going to make this presentation available online in the next few days, so keep an eye out for that. And again, we really appreciate you joining, and Parker and Neal and Megan, thanks for joining as well. And have a great rest of the day, everybody. Thanks so much.